Pre-AP, Precalculus, Chapter 2, free response number 11. No calculator. We have a table up here. We have some x values. We have function f and function g. The graphs of f of x and g of x are piecewise defined functions that consist of connected linear pieces whose domains are -4 to 4. Answer the following questions about the functions. Let's see. If p of x is x squared minus 3x minus 1, then for what values of x, we're trying to find x values, is p of x, this fella, equal to f of 1 minus 2 times g of -1? Show your work. So we got to find the x values, we got to show our work. You get 1 point for figuring out what the f of 1 minus 2 times g of -1 is 9. You get 1 point for setting that 9 equal to x squared minus 3x minus 1 and correctly solving it for -5 and 2. So how do you figure out what g of -1 is? Well, here's -1. G of -1 is -2. That's why that's there. How do you figure out what f of 1 is? Here's x is 1. Here's f of 1, which is 5. That's 5. A minus 2 times a -2 is a plus 4. Add those, you get 9er. How do you solve this equation? Well, you get all the terms on the same side, and then you factor. Two things that multiply to get -10, add to get -3. We get x minus 5 and x plus 2, so that each of those binomials is equal to 0, and we solve them. That concludes part A. Part B. Determine if f and g are even, odd, or neither. Give a numerical reason for your answers. So looking at our table of values, f is even because for every point x, y, there exists a point x, -y. So look at these ordered pairs. So -4, 3, look over here, 4, -3. Y's are the same, the x changed sign. -1, 5, +1, 5. Y stayed the same, x changed signs. 0, 2, x could have changed signs because 0 doesn't have a sign. So if you change the sign, it's still 0. So that fits into the even category. G of x, you get 1 point for saying it's even and giving a good reason. 1 point for saying g of x is odd because for every point x, y, there exists a point -x, -y. So -4, -3 is an ordered pair. Change both their signs, you get +4, +3. -1, -2 is an ordered pair. Change both their signs, you get +1, +2. 0, 0, change both their signs, you still get 0, 0. Part C. If p of x is 2 times g times a -x plus 3 minus 4, I immediately would change that so the coefficient of x is 1. It's much easier for us to determine what's happening. The point -4, -3 on the graph of g of x would correspond with what point on the graph of p of x? So we got this here, -4, -3, which is in function g. Then we're doing all this stuff to it. Where's that point going to end up? So explain your reasoning. That's this right here. And where would this point, what would be the corresponding point on p of x? That's this part over here. P of x graph would take g of x graph and reflect it horizontally about the y-axis. That's because we're multiplying by negative on the inside. Dilate it vertically by 2 because we're multiplying the outside by 2. Translate it to the right 3 because we are subtracting 3 inside the function. And it would also translate it down 4 because we are subtracting 4 on the outside. All that information is 1 point. Me rewriting p of x doesn't get me anything, although I think it makes getting the answer easier. So what happens if you do all this stuff to this? I would first write out what the rule is. xy for g is going to translate for p of x to being -x plus 3. And why is that the case? We are subtracting one negative on the inside, and then we are going to be doing a plus 3 because it translates to the right 3. And then as far as the y values are concerned, we are doubling the y values and subtracting 4. So it's 2y minus 4. So if you take the ordered pair -4, -3, which we were given, change the sign of the -4 as a +4, add 3 to it. Double the y value, 2 times -3, subtract 4 from it. 4 plus 3 is 7. 2 times -3 is -6. -6 minus 4 is -10. the ordered pair 7, -10. All this work is plus 1. All this work is plus 1. D, if h of x equals 3 times f minus g, represent h of x numerically in a table of values. Does h inverse exist? Give a reason for your answer. So, does this exist? Give a reason. So here's what I did to get these numbers. And I didn't show work for this, which really increased the chances of me making a mistake. So let's take 3 times f minus g. So what I did was I took 3 times 3, which is 9. Then you're supposed to subtract from that a -3, which is 12, until I got 12. Oh, didn't mean to scroll. Here, 3 times 5 is 15, minus a -2 is 17. Scrolled again. Here we got 3 times 2 is 6, minus 0 is 6. 3 times 5 is 15, minus 2 is 13. 3 times 3 is 9, minus 3 is 6. So that's the table. Does the inverse exist? Well, I'm going to give you the reason, and then I'm going to tell you if it exists. H of 0 is 6. H of 4 is also 6. What does that tell us? Therefore, h of x is not 1-to-1. You get 1 point for giving a reason and saying it's not 1-to-1. What does it mean if it's not 1-to-1? Well, it means lots of things, but one thing that strongly implies is that h inverse cannot exist. You get 1 point for saying that. That concludes free response number 11.